the end of today as well remotely.
Okay, you're seeing it. So let's see if this works. Always the problem with
To drag it there.
trying to, but seems to be difficult. Okay. So no.
And just mirror.
I think I've done that, but let me.
And it is this.
Okay.
Well, just figuring it out.
Well. Okay, so let's try like this.
Yeah, that's work. Alright.
Then, so I guess I have to talk through this.
Make sure it's on green.
Okay, hello everyone. My name is Luís ALves. I come from LIP, Lisbon, and I came here to talk to you about uDocker. uDocker, it's a tool mainly developed for users, not system administrators, but you might find some usage for this tool. And the goal was to run containers without Docker, without privileges, root privileges, and without system administrator assistance. The idea is also to empower users to run their own applications with their own libraries inside their own container, not caring too much about where it will land. So let's see if you like it or not. So, well, as you all know, scientific computing and containers, it's a bit difficult to sell containers on scientific computing. Scientific computing is a very heterogeneous environment, and researchers use notebooks, desktops, farms, cloud, HPC, or they want to use, and with that they have to deal with different operating systems, different libraries, different compilers, different you name it. And we have large concerns about portability, maintainability, and reproducibility of the runs or experiments or simulations. So we will need some consistent and portable way to run our applications. So our proposition is to use containers. I think all of you know how containers work. Raise your hands if you don't know. Okay, so I'm sorry, I will have to go through the containers particulars. But it's good to fully understand how uDocker how uDocker is different from Docker. So, as you all know, containers is not something very strange. It mostly takes advantage of the kernel features that were already there. So it uses the kernel namespaces. So kernel namespaces allow you to isolate some resources and control them. For instance, you have the mount, the IPC, the PID namespaces, the network namespaces, in where you can have different configurations in the same machine. C groups, you all know from Slurm for sure. Slurm takes takes advantage of C groups. There's also on kernel the seccomp that allows you to filter the system calls. The POSIX capabilities allows you to split or just give some permissions, some root privileges to some applications, so you can select what the application will be allowed to do on privilege mode. And you have change root, and also you have some things more security driven, like AppArmor and AC Linux. So we try, the containers try to take advantage of that. So what will happen on a container? So basically we are isolating processes on containers. So the idea is that inside a container it will be one or more processes running, but those will not see the processes from the host machine. And if they don't see processes or resources, they will not mess with them, hopefully. There's always ways to explore everything, but so let's have a look on a concrete case. Imagine that you have a host that is running Ubuntu. You download a container image, which is a CentOS 6, for instance. That image is while building the container, you define a mount namespace where you mount the file system. You say, from now on, this is your root inside the container. You also can bind some your own home inside the container if you want to have access to some data. You can define some PID namespace to provide isolation. And then you start the container and run your program. So how does it work for Docker? So to build Docker images, you often use a Docker file. A Docker file, it's quite simple file written on a simple language, in which you declare from where what's your base image. Then you put you just run commands inside. You copy data from your host to the image, and then you define what you are exposing. For instance, here you are exposing the HTTP port, and then you say which is the binary that you will run, or the application, for instance. And the funny thing about, or interesting thing about Docker images is that they are layered. So the first line, you will build the first layer. Then the second line, you will put the application there. You install the application. Then you copy something inside, or your app. And then you have the execution layer. The interesting thing about this is that if you want to go back, or if you want to make a change, for instance here, you just discard this top layer, and you can still reuse the bottom layers. This is also good if you want to do some minor changes to the containers that you already have, because each one of these layers has an ID, and the Docker can use those layers on several containers. So to create when you create a container image, like I said, you put your libraries and programs inside the file system. you define what it will see or be allowed to do. And the interesting part is that you can run, like on the example, you can run different distributions on the same host. So you can have a CentOS server running Ubuntu or running a Ubuntu container with Ubuntu GCC or Ubuntu libraries. But there's always a but, as you will see. In order to run Docker containers, you need privileges. So the system administrators will need to install the Docker daemon, and even to run a container, you will need sudo rights. Yeah. So we can go into more detail here. So you need root privileges to install, set up, and run. That might be a concern on multi-user environments. The Docker API does not limit privileges actions. So if you have access to the API, if you give access to your users to the API, it might do something bad. And the reason for this is that Docker is designed more like a lightweight virtualization. So it's kind of a hypervisor, let's say, and should be installed by operators and not users. That's difficult on batch systems, as you all know. We don't like anyone running as root beside us inside batch systems. So during the Indigo Data Cloud project, we proposed to develop something that would, at least would try to run containers on user mode. So we tried to answer these questions, or just a detail here. We developed two pieces of software, uDocker, and the goal of uDocker would be using Docker on batch systems with all the limitations that have. And the other uDocker that I'm presenting here, it's how to run containers without Docker. So can we download container images? Can we run without layered file system? Can we run them as a normal user? And can we enforce container metadata? So for that, uDocker must run applications encapsulated in Docker containers. So we will pick a Docker container already done, and we will try to run it. No Docker, no root privileges, without system administrator intervention. So a user will be able to run a container without the sysadmin knowing about that. I'm not sure if you like that. Yeah, still having process controls and accounting, and it will run on interactive and batch systems. So, and the one advantage of uDocker is that, unlike Docker, it's not bound to a single Linux kernel technology. So we don't use the namespaces. Unless you will see that we have several modes, so we can use or not, but we are not bounded to that. So, and that's interesting because in some HPC systems, you might be dealing with some old kernels, and that's or even on farms and grids. So uDocker is written on Python mainly. We have some C, C++, and Go blocks inside the Python file. It runs on CentOS 6, 7. At least we have tried these ones. It works well. Or any distro with 2.7. And as features, we have a a command line interface like Docker, mostly like Docker. We don't allow to do everything because it's a different tool. We can pull containers from Docker Hub. We have a local repository on the user's home. And we have modular engines to execute the container. This is a view of the uDocker repository. That the uDocker repository is inside the .uDocker folder at user's home. And as you can see here, we have the layered file system from a Docker image. And that during the create phase, it will be flattened into the root of the container. More in-depth view here. So this is the file system from the host. Then inside the uDocker repository, you will find a container. This is the ID. And inside the container, with change root, the user will, whoever is inside the container will just see this as root. So no possibility of seeing the rest of the file system. Yeah, like I said, it uses change root to give a view of the container file system. It flatters the layered file system. Yeah. So about the execution engines, when you start using uDocker for when running a container, you can choose between different methods because different applications may or may not have some, or they can take advantage of some, or they may not even run if you don't use the right method. So by default, we use ptrace. This is a interesting trick, but that basically that's the trick inside uDocker. So basically, when executing, you extract the path of the application, all the paths, and you reread them. So that's how we achieve the goal of giving. As you will see later, you might be feeling that you are root inside the container, but in reality you are not. So we'll see. And we can use library call interception, and also we can use rootless namespaces whenever they are available, because these are a quite new mode that not every kernel allows that. These are all the methods that we can use, with some differences between them. So ptrace, rootless containers, fake root mode, and also we are now using singular. We can also use singularity. Whenever singularity is installed on the system, we can use singularity. The syntax is quite similar to Docker 1. And how do we install uDocker? Basically, we don't install. Well, let's say we will extract something, but we will download the Python file from GitHub. Let's say we change the permissions of the file, and then we can run it. So the thing here, when you do Docker install, basically you are creating your .uDocker repository. So as you can see, a user inside the batch job, if he has internet connection, or even if he sends the file, he will be able to run their own containers. So you can, like Docker, you can search for images. You can pull images. Here you can see the layered file system being downloaded. You can list the images and create the container. While creating, you are basically converting the file system into one single, not layered file system. You can list the processes running, and you can run the container. This is an interesting thing, is that when you run this Ubuntu 14, you are inside the container. You can even install stuff because you are tricked to believe that you are root. But don't worry, the process is running as a user, a normal user. So just inside the container, he thinks he's root. So you can install even stuff inside the container if you want to. One other way to use this is that imagine that you have your container and you want to see your home folder from the host. You can just run the container as the user, mount your home, the host home inside the container. That will be on the same on this folder inside the container, and maybe there's a typo here. I have to check. It's inverted, and then you are inside the container seeing your files from the host. So issues and limitations. Every software has some. The ones that we can point out now is that ptrace is slow. Of course, we are extracting the path and rewriting the path. Yeah, it relies on a complex stack rewriting. The library call interception, sometimes it doesn't work as we wish. It depends a little bit of what kind of application you are running. And namespaces, like I said, it's not extensively tested still. We made some experiments. At the end, you will find a link for a paper that we submitted and was accepted regarding these experiments. So, and this was we were trying to compare performance. And for Lattice QCD, we run some workloads on Sesga. I guess you are from Sesga. I think on Ian and also on Altamira. Where is Altamira? Also Spain, right? Yeah. uDocker was also produced with Spanish colleagues, so it's not just Portuguese. And the native file operating system is CentOS 6.9. The uDocker that we were running there, or the container that we were running there, was a CentOS 7. And I think performance-wise, it was not bad. With the advantage of using the modern libraries or the more recent libraries for the. So here is another graph on P mode. We were using OpenCL and NVIDIA GPUs. The native machine was a CentOS 7. And it's so often you have to run old codes that rely on old libraries, and your systems don't have they don't have those libraries. And here we were on a CentOS 7 running a Docker with Ubuntu 16 and a uDocker with also a uDocker with Ubuntu 16. We also had uDocker with the CentOS 7, and we had a very good performance. And I think the reason for this is that the libraries from Ubuntu may perform better than the ones from CentOS. That's arguable. That's our speculation. And as you can see, it's the performance is quite similar to Docker. Another graph, this time using P1 or ptrace mode and F3, which is fake root mode. The same type of software, and we also got some quite good performance. This is another application that we tested. It's from phenomenology, sorry, difficult word. And interesting part is that we got fast compiling and a very similar performance as Docker. This is comparing to the host. So as you can see here, the decrease on performance is not that big comparing to the host. This is the way we were running those tests. So basically, once you have uDocker there, you just define you say run, use host authentication, map these volumes inside the container. You will be user 000 inside, and then run the master code process with all this. No, this is the name of the container, sorry. You will run bash with these arguments. So, as a wrap up, how this is good. So uDocker uses Docker files. It's quite easy packaging tool. It's a well-defined and efficient format. We can use Docker Hub to get the images. Portability, I think that's very interesting, because you can take your container and just run it anywhere you find a Python 2.7. Maintainability, it's also quite easy to maintain. You can reproduce experiments, which is, I think, more and more it's important to keep the same environment for if you want to run something now and 10 years from now. Hopefully you will have the same results if you use the same libraries, the same GCC, the same stuff. You can reuse it quite easily. Security-wise, I guess that's way better than using root privileges. And we have quite similar to bare metal performance. This is a link for our paper. Oh, I was fast, I guess. You can have a look. I will share this presentation. And, well, thank you. Please try, see more, give feedback, contribute to uDocker on GitHub. Thank you. Any question?
Thank you, Luis. Any questions?
So your worst case, like proot performance or proot, I don't know what they pronounce it, but it was only like 20% over the. Like, do you have any examples that are worse for proot? Because it just doesn't. I don't know. It seems like if it's that low all the time, why would we ever have bothered with the challenge of, say, singularity and doing? But
on which one? This one?
For nothing, like for doing nothing. That's not too bad.
For one improvement job, sure. For 1,000.
Anyway, what are when you're hitting a lot of syscalls and you have to do a lot of renaming, that's where you get the high hit, and when you don't,
if you use ptrace,
almost.
Well, that's something that that's a a compromise that you have to accept, because what you are doing is, but this is not a tool for system administrators, right? It gives liberty for the user, just pick their own code, and if they have some machine time, okay, let's use it here, for instance, for a grid. That's very good, because you don't care what's there. There's Python, there's a Linux kernel, so I will use my code, and on every node I will have it will run. That's the thing.
What about comparing it to Singularity? I guess you didn't show, because we happen to have Singularity in a lot of places in HPC now, and you should be able to get much better performance out of.
You will, right?
I don't have numbers for the tests with Singularity, but it's working with Singularity. In our farm, we have Singularity installed, and we use uDocker with Singularity.
Do you have to tell uDocker to use Singularity, or just
yes, you define the mode. So I don't have the example here of the command line, but
yeah. So a user has to tell, I know Singularity is there.
Yes. Yes, I don't have the example, but basically use this S1, so modes S1.
Well, I was going to also have you compare R1 to P1.
R1 with F1, you mean?
P1, like Perut versus runC, like how or say runC versus Singularity, maybe that's better. Like, do you find that they're pretty comparable, or?
I cannot answer that, because the experiments have been made by the way, the main developer is Jorge Gomes, and I don't know those details, but I can ask him and send you some feedback on that.
I'm wondering how you start up using uDocker to start, for example, MPI program on multiple nodes with batch system, for example, use SRAM. Because, and does it depends on system level installation of MPI versions and InfiniBand drivers. Because with Singularity, we had the problem that we had a Singularity image, and then we have to run it through srun with Singularity, and then it apparently depends on the system, so which version of MPI you are having, and the drivers. So how do you work with that? And then do you need to install everything within uDocker, and then with compatible versions on the host?
So the thing is that if you want to have a comparable result, you will need to put everything inside the container. So your program is loading everything that you need from the container, the libraries that you have there inside the container. So that way you will not rely on whatever is on the machine.
Yeah.
If you want to use MPI,
Yeah.
then I think you have to.
Yeah, you have to.
Because you'll have to spawn a container on each host that has
Yeah.
MPI inside, but also outside the MPI.
Depends on how much acceleration you need.
No, but they have to
No,
be able to communicate.
yeah.
So you need MPI.
Just-
Yeah.
You can just say, oh, just use TCP, ignore InfiniBand.
But you still need MPI.
Yeah, you can do that.
Yeah, sure. And it has to be compatible MPI, one that's able to talk
Yeah,
to the
exactly.
MPI inside.
On multiple nodes.
But-
Initially, they
but-
have it Singularity.
You can do it in the dump, which doesn't use any of the acceleration. Just do TCP.
Sure, but it has to be
But still,
compatible
it has to talk with each other.
Like having an MPA pitch in the host and an open MPI in the container, that's not
It will not work.
But they won't be able to talk to each other, but if the container only uses the same between all the nodes.
the container has to talk to an MPI on the host. No, it has to.
But you have different versions of MPI on.
Yeah, I mean, yeah, if you have your MPI version inside a container and it's different from the one you're using on the host, it won't be able to run. It won't be able to talk with the other.
In that case, I would say I'm not sure how they did this, but you can check how they did this. But on that case, they probably were relying on, because you can still use some resources, they were probably relying on the MPI on the host. So I don't have an answer for that right now, but my guess is that in that case they were using the host MPI. But the common...
Because you show some result of running on like 250 course. I'm
Yeah.
wondering. So
But
So
yeah,
how that was
those
done?
are quite large systems. The ones that I've shown.
yeah,
So
but
we can do that. Yeah. So there's not. I guess it's a quite homogeneous system. The SESGA. Okay. So I have to check that because I haven't done these runs. But my guess is that in that case they were using the MPI
so the
from
same version of MPI
Yeah.
in the uDocker and on the system.
No, you don't. In that case, you will not need to use the one from inside the container. It's just if you want.
Ah, okay.
How you
So
expose this into the container? You combine it. Specific files? Or okay. There doesn't have to be a path. Yeah, you can expose stuff from
Yeah.
outside into the.
Yeah. On. Sorry. Well, it relies on the stack that you are using, so it will
So-
be able. Again, sorry.
You could.
Yeah, yeah, yeah. Yeah.
You may have to recompile the stuff specific to the
You could.
okay.
Yeah. Well, I will point that down.
So one other question / concern I have, so it's very nice that you give people flexibility. They have a container that works, they want to use it wherever they have access to.
Hmm.
They don't even need to talk to the sysadmins,
Yeah.
that's good because
Yeah.
we don't have time to talk to them. It's very good, but so there may be a small performance hit, hopefully
Mm.
not too much if they're
Yeah.
not too system call heavy, but they're probably gonna use a generic container because it has to run everywhere. So
Yeah.
the same question
Yeah.
as Rob had for the talk this
But
morning.
in that case, I'm sorry, could provide. Then the sysadmin can intervene and
They
say,
could, but if
look,
they
you
don't come
can.
and talk to you, you won't know.
Well, I'm not saying that this takes out of the picture completely the sysadmin. In this case, if you want to use Singularity, they will be active. But yes, the sysadmin may do some flavor container image just for their systems. Why not?
But then the sysadmin either has to be told or has to notice that.
No, I'm not saying that sysadmin is not aware because we don't want him to be aware.
No.
It's just we don't want to give more trouble to the sysadmin because, like you said, we normally don't have time for everything.
Yeah.
And the thing is that the users that feel comfortable with containers and just build their own containers, they are able to run it whenever they find some machine time.
Yeah, that's
Which is good.
that's very
right?
good,
Yeah.
but it could also be bad because
Like everything.
they may be able to they may be good enough to get the container working, and uDocker makes it very easy.
Mhm.
But they may not realize that the container they are using is not optimized for the system they are running it on.
True.
So they may be
In fact,
losing performance not
True.
through uDocker, but just because of using a generic build.
it's almost likely that he would. Because in most cases,
But-
Kind of have to make sure it works.
Yeah, but I think that's the case for most scientific software, in which they are most of them are not using the most optimized version. So I would.
I'm not sure if that's true. if like we spend a lot of time in EasyBuild to try to make sure we get the most
Yeah,
out of
yeah.
the hardware, which is why a lot of software that we provide.
So then, and considering that we are on an EasyBuild conference or event, I will place the challenge. Why not EasyBuild building the images?
sure. It
Why not?
could. And it even could in a fat way. That it supports multiple architectures and
Yep.
it just has auto detection. So
Mhm.
GCC can build fat binaries. If it sees this thing has AVX2, okay, I can use it. If it doesn't, I'll fall back to SSE2. And you can build a big fat container that can basically run everywhere
Mhm.
and still have good performance.
Yeah.
That's just not the norm right now with containers.
No, of
But
course.
it's something we
But
can work
I think we
towards.
are converging because more and more
Hopefully.
we want to isolate, give more access to more resources without putting more trouble into
That makes a lot of sense.
into the stack of the sysadmins, and
And I think, like you said, EasyBuild can definitely help there.
Yeah.
And we're working on
For
that
sure.
to
Yeah.
generate. Now we're focusing on Singularity to let EasyBuild
Yeah.
let Singularity build containers, and we can do the same thing with Docker, and then they could be leveraged by uDocker. Yeah.
We are happy with that because we can still run the Docker images. So
Yeah.
yeah.
Okay. Any more questions? An easy config for uDocker would make sense.
Yeah, I think we can look at that and try.
Yeah, that would make sense.
Thank
Hear
you.
me.
So one last question. Can you compare uDocker with Charlie Cloud? Because it seems for me very similar with what you're doing, so you should check.